Namaskar. It is rightly said that students can learn the arts as well as learn through the arts. Education is not only about the learning the theories or solving difficult problems. The most important aspect to education is to ignite creative and thoughtful minds so that they can use their skill and innovation for better tomorrow for everyone. Classroom teaching should be such that the students not only understand the concept but also retain them. The existing school structure consists of 10 plus 2 framework designed for the children aged 6 to 18, which can be seen here. There is no coverage for children below the age of 6 years in the existing 10 plus 2 structure. The NEP 2020 aims at reconstructing the school curriculum and pedagogy into a 5 plus 3 plus 3 plus 4 structure, covering children aged 3 to 18 and aims at making the learning experiential. As per the NEP 2020, the foundational stage will consist of 5 years of flexible, multi-level, play activity based learning and the curriculum and pedagogy of ECCE, which means Early Childhood Care and Education. The preparatory stage will comprise of 3 years of education building on the play, discovery and activity based pedagogical and curriculum style of foundational stage as well as aspect of more formal but interactive classroom learning. In order to lay a solid groundwork across subjects including reading, writing, speaking, physical education, art, languages, science and mathematics. The middle age will comprise 3 years of education building on the pedagogical and curricular style of the preparatory stage, but with the introduction of the subject teachers for learning and discussion of more abstract concepts in each subject. Secondary stage will comprise of 4 years of multidisciplinary study building on the subject oriented pedagogical and curricular style of the middle age, but with greater depth and greater critical thinking, greater attention to life aspiration and greater flexibility and student choice of subjects. In accordance with the National Education Policy 2020, learning should be holistic, integrated, enjoyable and engaging. This can be incorporated in the school curriculum with the aid of experiential learning. Experiential learning is about learning by doing and then reflecting on the experiences that makes it easier for students to form a link between the concepts they learn in classroom and the situation they observe in the real world in their daily lives. It includes various pedagogies like hands-on learning, art integrated and sports integrated education, storytelling based pedagogy, etc. The cycle of experiential learning includes the steps of experiencing, reflecting, conceptualizing or thinking, acting or experimenting. Out of the various pedagogies through which experiential learning can be executed, in today's session I would like to elaborate on how art integrated learning can be used in various aspects of mathematics. Not very long ago, art was not considered as a very important subject in school curriculum or academics. Not very long ago, art wasn't considered a very important subject in school curriculum or academics. However, now as ideas have metamorphosed, art integrated education or learning through arts and learning with arts is considered as one of the most important pillars of the classroom pedagogy. Art integrated learning is an interactive method to teach students various concepts from the curriculum through visual or performing arts. Visual art is intended to be perceived primarily by vision, such as painting, photography, printmaking, clay modeling, sculpture, applied arts, crafts, etc. On the other hand, performing arts are carried out using expression by using motor or vocal skills, facial expression and body movements like dance, music, theatre, puppetry, storytelling, martial arts, etc. This method not only helps in making students understand different concepts in easier manner, but also makes learning joyful and engaging. It helps in enhancing cognitive, psychomotor, and socio-emotional domains of students. Art integration is different from art integrated education. The former aims at providing a platform to encourage verbal and non-verbal sensory explanations in the form of any performance like music, dance, painting, etc., while the latter aims at exploring various concepts of the school curriculum using different forms of arts, that is, using arts as a central tool for education. Professor Jerry P. King, in his book The Art of Mathematics, has described mathematics as an art by stating that the keys to mathematics are beauty and elegance, and not dullness and technicality. Indeed, mathematics and art are two domains which can be used as a tool to learn and explore each other. In order to incorporate art as a teaching aid in our school curriculum, we first need to decide on the topic which we want to teach. Next, keeping the topic in mind, we need to design an art integrated activity which students can easily perform individually or as a team in the classroom itself. So, out of the numerous activities that are possible to teach any particular concept, we have to choose one for which all resources are easily available, and also the activity can be easily conducted within a stipulated time frame. Now, I would like to introduce some activities for different school level which will further elaborate how we can integrate art with mathematics. In order to incorporate art as a teaching aid in our school curriculum, we first need to decide on the topic which we want to teach. Next, keeping the topic in mind, we need to design an art integrated activity which students can easily perform individually or as a team in the classroom itself. Out of the numerous activities that are possible to teach any particular concept, we have to choose one for which all resources are easily available and which can be performed within a stipulated time frame. Now, I would like to introduce some activities for different school levels which will further elaborate how we can integrate art with mathematics. In foundation level, let us consider an activity to demonstrate the concept of representation of number, that is the place value and face value of the numbers. For this activity, we will require some sticks, squares, some thermocol balls and a rectangular piece of thermocol. To begin with, we will ask the students to stick 7 squares at equal intervals on the thermocol box. Next, we can choose any number, for example 24301, and then tell them to insert 2 balls on the first stick, 4 in the second stick, 3 in the third, 0 in the fourth, and 1 in the fifth. Thus, this setup now represents 24301, where the number of balls in the sticks denotes the face value of the number at that position, and the position of the sticks indicates the place value, where the rightmost stick indicates one's place. Like this, we can give them any random number and ask them to represent it using thermocol balls and sticks. Or we can use a model for the students and ask them what number is being represented. Like this, we can give them any random number and ask them to represent it using thermocol balls and sticks. Or we can make a model for students and ask them what number is being represented. Using the same material, we can design another simple activity based on different shapes. For this, we can ask the students to arrange the balls in different ways to form different shapes. In the middle school level, for example, in geometry, when teaching about spheres, we teach the surface area of the sphere is 4 pi r square. Now for this, any spherical ball can be taken. We can ask our students to take a piece of string and wound it around the entire surface of the ball. So now the length of the string indicates the circumference of the ball. Next, students have to cut out 4 circles, which we can observe here like this, and from a piece of paper of radius r units. It can be observed that a string used earlier exactly covers the surface of 4 circles. Now, it is known that surface area of a circle is pi r square. Hence, it can be easily verified that the surface area of a sphere is 4 pi r square. At secondary level, while teaching congruency to students, we teach that two congruent triangles can be superimposed on each other by placing the corresponding sides on the top of each other. For this, students can be asked to make two paper triangles as shown, which are congruent, and then try to superimpose them. They can also be asked to observe that the triangles don't superimpose if the corresponding sides are not placed on the top of each other. At senior secondary level, let us consider the chapter of conic sections. For this, we can ask our students to form a paper double cone and then cut the cone at different angles to observe how the various conic sections are formed, like we have circles, we have ellipse, we have parabola, and we have hyperbola. In a similar manner, for any class, we can try to use different art integrated learning techniques for teaching mathematics. Now, art integrated learning is not only limited to classrooms or class timings. It can be practiced at various instances like free periods, school assemblies, school sports, or any event celebrations. For instance, in school sports, students can be made to form different shapes during drill, or they can use various shapes to form different rangoli patterns to decorate the school during any event. The various artworks our students produce out of these art integrated sessions can be displayed on the classboard or during school exhibitions or in school magazines to further motivate them. In order to execute art integrated learning, we as teachers and facilitators must ensure that we don't become judgmental, comparative, or competitive between the works of different students. It is a joyful and engaging method of learning where students can express their imagination without any fear or limit. In true sense, it is a method of teaching where there is no boundary of absolute right or wrong, and students can come up with their unique ideas and ways to express or demonstrate a particular concept. In this way, we can integrate art with various concepts of mathematics. To conclude with, as teachers, our aim is to make learning engaging, interactive, joyful, and comfortable for our students so that they can retain the various concepts they learn. This, as we have seen, can easily be done by making learning not only educative but also educational. We may choose any form of experimental learning pedagogy as a tool, depending upon the class, the subject, the topic, the resource available, and other aspects. In this particular session, we have seen the various aspects of art integrated learning in mathematics. Our goal is to integrate arts and science and guide our students to express different mathematical concepts through various art forms. Thank you for being with us during this session. Namaskar.